Hi everyone and welcome to STEM School. So in today's video we'll be looking at the rules of indices, and there are many rules to go over, so today I'll explain all the rules, and in my part 2 video we'll do the exam questions on indices, so be sure to check that video out. So we'll start off with what indices actually are. So indices are just another way of saying power, so those are the little numbers to the top right of a letter or a number base. So a bit of terminology here. Here we've got x to the power of 5. Well, this x here, well, that's called the base, and the base can be a number or a letter. Now this floating 5 here, that's the power, alright? So like I said, we can have a number base as well. We could have 5 to the power of 3. This 5 here is also the base, okay? And there are a few things that you need to remember when dealing with powers. You need to remember that the power only affects a base and not the number in front of the base. So if we had, 4x squared, something like that. Well, this square term here, the power, that only affects the base, which is x here. So this should be read as 4 multiplied by x squared, okay? But if we had 4x in brackets and then the square term outside the brackets, now this would be 4 squared x squared. The power of 2 affects everything in the brackets, and we're going to discuss this later on when we talk about the rules. And the last thing to note is that indices don't mean multiply. So if I had 4 to the power of 3, this doesn't mean 4 times 3, okay? That's not the way to read it. 4 cubed should be read as 4 times 4 times 4. So you're multiplying it 3 times, that's where the power comes from. Alright, so let's start with rule 1. And rule 1 states that anything to the power of 0 is simply 1. Okay, so we have a to the power of 0 is equal to 1. So let's do an example. We have x to the power of 0. Okay, using this rule, we know the answer will simply be 1. Right? And as I mentioned before, the base can be a number or a letter, so let's try a number. We'll try 5 to the power of 0. It will be the same thing, that will also equal 1, right? Now, let's make it a little bit more complicated. Let's add a number in front of the base. Let's try 6x to the power of 0. So as I said before, the power only affects the base, so this should be read as 6 multiplied by x to the power of 0. And x to the power of 0 is simply 1, so 6 times 1 is equal to 6. And there we have it. Let's do rule 2 now, and this rule states that anything to the power of 1 is just equal to itself. So you'll notice anytime we deal with numbers, it's just normal practice not to write the 1 power, as it is just implied, right? So let's do an example similar to before. We've got x, but this time we've got to the power of 1. Now using this rule, this will just come out to x, okay? And let's try a number base. Let's try 5 to the power of 1, right? So using this rule, the answer will just be 5, right? Now let's do a number in front of the base. Just don't get confused with this. The power only affects the base. So this will just simply be 6x. There we go. Alright, so this third rule is about multiplying like numbers or like letters with powers. So if you multiply a to the power of m by the same base, such as a to the power of n, what you do is you just add the powers, okay? So you have to make sure that it's the same base that you're dealing with. So let's try an example. We've got x to the power of 4 multiplied by x to the power of 3, right? So we have the same base here. This means we can use this rule. So it will be x to the power of 4 plus 3. Okay, you just add the powers, and that will come to x to the power of 7, right? Let's try another quick example. We have 3 to the power of 5 multiplied by 3 to the power of negative 2. So we have the same base of 3. We can use this rule. All we have to do is just add the powers. So it'll be 5 plus minus 2, okay? And when you compute that, that will just be 3 to the power of 3. Okay, so this is the same as saying 3 times 3 times 3. And when you figure that out, that will just be an answer of 27. Okay, let's try a little harder example. We've got 2x to the power of 4 multiplied by 3x to the power of 5. Okay, so we've got the same base of x here, okay, so we can use this rule. What you have to do is multiply the numbers in front of the bases. Okay, so 2 times 3, well that is 6, right? Then you write the common base, which is x, and using this rule you just add the powers, so 4 plus 5. Okay, so that will just be 6x to the power of 9. So just remember, multiply the numbers in front of the base. For this fourth rule, we're dealing with dividing. So if we are dividing something to a power like a to the power of m divided by the same base of a to the power of n, what you have to do is just take away the powers. Okay, so it's very similar to the previous rule of multiplying, but this time you take away the powers. So usually you'll see in this form we have a fraction, right? So let's do an example. We've got x to the power of 10 divided by x to the power of 8. Okay, so we've got same base of x, so we can use this rule. So what you have to do is take away the power, so the answer will be x to the power of 10 take away 8, and that will just be x squared. Alright, let's do a number base this time. We'll do 6 to the power of 7 divided by 6 to the power of 3. Okay, same base, so it will be 6 to the power of 7 take away 3. We're just subtracting them. So this will be 6 to the power of 4. So this will be 6 times 6 times 6 times 6. So 4 times you're doing it. That's what the power tells us. So the final answer will be 1296. There we go. Now let's try an example where we have a number in front of the base. We've got 30x to the power of 10 divided by 6x to the power of 5. Okay, so you have to deal with the numbers in front of the bases separately. We just have to divide 30 divided by 6, so that will just be 5. Okay, then we write the common base, which is x, and then you subtract the powers. 10 take away 5, right? So the final answer will be 5x to the power of 5. And there we go. So rule 5 is power of a power rule, which is when you raise everything inside a bracket to a power. What you have to do is multiply the power inside the bracket to the power outside the bracket. So we have a to the power of m in a bracket, and you just multiply by the n, which is the power outside the bracket. So let's do an example. We've got x squared, and that's in brackets, and you're raising everything in the brackets to the power of 3. So what you have to do is x to the power of 2 multiplied by 3, and that will just be x to the power of 6. There we go. So let's do another example. Let's do a number base. We have 2 to the power of 5, right? And then we're going to square everything. Okay, so this will be 2 to the power of 5 multiplied by the power outside the bracket, which is 2, and that will be 2 to the power of 10. Okay, and when you compute that, the answer will be 1024. Alright, now let's do another example. We have a number in front of the base. We have 4x to the power of 4, and let's cube everything, right? So everything inside this bracket is affected by the power, okay, even the number in front of the base. So we have 4 cubed, right? Then let's deal with the base. So we have x to the power of 4, and you multiply it by the power outside the bracket, okay? So 4 times 4 times 4 is 64, right? Then x to the power of 12. And that's the final answer. Let's move on to negative powers. And normally we don't like dealing with negative powers, so we want to somehow express it as a positive power. And to do that, what you have to do is use this rule and take the reciprocal of the base to the power. When you hear the word reciprocal, just think 1 over, okay? So we have a to the power of minus m. What you're going to do that is put it in a denominator with a positive power, okay? So as simple as that. Let's do an example. We have x to the power of negative 4. Now if you saw that in like an expression or an equation, we don't like dealing with that. What we want to do is convert it into a positive power. So you take the reciprocal, 1 over x to the power of 4. So you have a positive power in the denominator. Now let's do another example. We've got 3 to the power of negative 2. Okay, So let's put a reciprocal, so 1 over 3 to the power of 2. So we've got a positive power. And when you compute that, it'll be 1 over 3 times 3 is 9. Okay, so 1/9 is the final answer. Let's do one more example. So we'll have a number in front of the base. So 5x to the power of -2. So what this can be read as is 5 multiplied by 1 over x squared, right? So you deal with the number set in front of the base separately. The number in front of the base isn't affected by this power, right? So then the 5 can go in the numerator, so 5 all over x squared, okay? And finally, rule 7 is about fractional powers, and this is the most difficult rule to deal with. If you have a fractional power, it can be rewritten in this form that allows you to calculate it easier. You'll end up using this rule to go back from one form to another, right? So let's do an example. The first example I wanted to show you is if you have x to the power of a half. Okay, this is quite an important example. Now, let's use this form to this rule to rewrite it. So the 2 in the denominator goes in front, so it'll be 2. Then we have the root, and we have x, and then we have the 1 outside the root. Now, this is the same as just root x, okay? Now, the square root operation is a very common operation, so and it is practiced not to write the 2 and the 1 there, but you have to imagine it being there, right? So let's do another example. We have 8 to the power of a third, okay? And we want to rewrite it in this form, right? So we have the 3 goes in front, then we have 8, and then we have the 1, okay? To compute this, what you do is kind of separate it. So just imagine this, and we want to calculate this part first, and then we'll worry about the power later on. So this is essentially saying I want to find the cubic root of 8. So in other words, what times what is equal to 8, right? And you'll work it out that 2 times 2 times 2, well, that equals 8. So the answer to this section, well, that will be 2. Then we deal with the power, so 2 to the power of 1. So, as I mentioned before, anything to the power of 1 is just equal to itself. So the answer will just be 2. Okay? Now, let's do a harder example. Let's do 9 to the power of 3 over 2. Okay, so let's rewrite this. So we have the 2 in front, then we have 9 in the root, and we put the 3 on the outside. So as I said before, we worry about this section first, then deal with the power. We'll cube the answer that we get for this bit. So this is the square root of 9. Okay, so the square root of 9, so essentially what times what is equal to 9. So I know that 3 times 3 is equal to 9. So the answer for this bit will just be 3. Okay, now let's bring this power of 3 into it. So this is the same as 3 times 3 times 3. So the final answer will just be 27. Alright, so this is a wee summary of all the rules to copy it down easily, and I hope this video has helped you. Join me in my next video where we'll do some exam questions on indices, and as always, please do like and subscribe, and I'll see you in the next video.